Hello, my name is Daniel with the matrix number 77943, and I am going to present my circuit alongside with the Microsoft PowerPoint presentation slides first. Moving on to the video. Okay, so we're at the presentation slides, but this is the schematic diagram for the circuit itself. 1.5 volt battery is going to power up the whole circuit, which is going to be connected to all three of the resistors here, which is all in 1k ohm, and R1 will be connected in series with R2, and then both of them are going to be in parallel with R3. So right here is the circuit in real life. This one is the positive terminal, which is connected in series with R1. It is there's another jumper that is going to be connected to create a node so that R2 is in series with R1 right here. And then another jumper is going to be connected to the other side so that it will be parallel towards R2. And then yada yada yada, then another jumper, so that it is connected to the negative terminal of the circuit or the battery. It is so that the circuit is completed. So yeah, that's basically the circuit. Okay, right here on the multimeter, we're going to put the scale into 10 for DC voltage. So we just connect it parallel to the resistor. This is the same process all over and over again for each resistor. So from here the reading is taken. This is 0.5. This one is R3, which is 0.5. This part is for current. We're going to change the scale to DCMA. It is not clear in this camera, but it is in the scale of 2.5. To measure current, it should be measured in series with the resistor. So positive side is going to be connected to the resistor, and the negative side is on the other side of the jumper right here. So as you can see, it is 1 milliamp. The same process repeats all over and over again for each resistor. Connect back, and then from here we'll calculate for R3. Same process, but as you can see, the reading is 0.5. And for the last one, we went to resistor 2. Positive to the resistor. So we can see that it is 1 milliamp. Okay. So the following are my measurements from as demonstrated in the video, and then right here is the comparison between the actual value and the theoretical value. There are not much difference except for total voltage and partial total current. So the total current has the biggest difference. I'd say the reason for this is a lack of understanding of the multimeter itself, since it's an analog multimeter. So it's a bit difficult to really understand the scale of the multimeter as for beginners like us. So the following is my discussion. The theoretical partial voltages and the partial current across all of the resistors are the same. This means that the circuit constructed is correct alongside with correct method to measure each respective values. To measure voltages, the multimeter, which was an analog multimeter, it needs to connect in parallel to the resistors. To measure current, it needs to be connected in series to the resistors. The only difference in values was the measured value for total voltage and total current. This is due to parallax error, as I mentioned just now, as the weakness of using the analog multimeter is the observer needs to observe the needle precisely, which is close to impossible due to the fact that the analog multimeter is less precise as compared to a digital multimeter. Right here is the conclusion, which is from this experiment both objectives were achieved successfully. The circuit was constructed properly as demonstrated in the video. From this experiment too, to properly use the multimeter achieved. In conclusion, the experiment was a success. Thank you. Moving on to the next part of the video. Okay, so this should be the end of the video. Thank you for watching, and that's it for my presentation. Thank you.